Okay, this game called Penney, Ante, it's a probability game, and the math on it actually turns out to be pretty complex quickly. So how the game works is you flip a coin, and you flip it 3 times, and you want to predict the outcome. So you can predict heads, tails, heads, and the other person could predict tails, tails, tails. But if the other person picks first, and I pick second, there's an algorithm so that I'm going to win more than half of the time. And really, where we're going with the Common Core on this problem is the kids are going to try and decipher what that algorithm is. First, one of the students picks an outcome like heads, tails, tails. And then I pick an outcome heads, heads, tails. And we start flipping the coin, and we write down what comes up. We say heads comes up, flip the coin, then tails comes up, then heads, and then tails, and then heads again, and then heads, and then tails. Since this is that I picked, heads, heads, tails, I win the game. Is it possible for the other student to win? Yeah, it is, but it's going to be much more likely for me to win because of the algorithm that I chose. And the algorithm, the secret game here, is I reverse this and make it a heads, and then I take their first 2 and put them as my second and third place. So I'll play the game with my class today, and then you'll see how the game's played. And then when we're done, the kids are going to spend a little bit of time writing a paragraph or 2 explaining why it was that I won more times than they did because of the algorithm. And then I'll have a couple kids on the board explaining how they figured it out, and then I'll scan some of their paragraphs. Okay, so if I take a quarter and I flip it, there are 2 outcomes. If I flip it 3 times, there's 8 outcomes, right? I could either get a heads and a tails. If I get heads, I could either get heads or tails. Or this tails, I could have heads or tails. If I go heads, heads, there are 2 outcomes from here. Heads or tails, heads or tails. So I can see if I flip a coin, I have 8 total. So what's the probability that I flip this coin and I get heads, tails, heads? So then we'll play a game right here, Nathan. I'm going to flip this coin, or actually you can flip it 3 times. You flip it 3 times, but before you start flipping it, why don't you predict the 3 outcomes? Just pick 3 outcomes you want to pick.
Tails, head, tails.
Tails, heads, tails. And I'm actually going to pick tails, let's see, tails, heads. We'll start flipping that coin. Whoever gets their outcome first wins the game. Everybody understand how the game works? So, I mean, if it, we'll just keep flipping until either this outcome comes up or this outcome comes up. If this outcome comes up, I win. If this outcome comes up, Nathan wins.
It's tails.
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 No.
Head.
No, you did.
It's a 1 in 8 shot.
How could I cheat? What is the likelihood of that coincidence?
1 in 8. It's perfectly probable.
All right, let's do it again. You want to change coins?
Yeah.
All right. So Brandon's gonna play. So Brandon, pick your outcome.
Heads, heads, tails.
Heads, heads, tails. This is Brandon. And then I'll pick. Let me see.
Can't pick the same thing?
All right, I won't pick the same thing. I'll pick tails, heads, heads. I don't know, just some random outcome. Go ahead.
Tails. Heads.
No.
Mr. Schwartz, if you win.
Heads.
I'm going to Reno. I got to
This is impossible.
Actually, what is the likelihood of that happening 2 times in a row?
Very 116. Mr. Schwartz, are you ready for it?
This actually is an amazing coincidence. Did everybody see that? What is the probability that I win 2 times in a row?
116.
Right? 1/8 and then 1/8, which is 1/64. Very unlikely. Yeah. You want another coin? Let me take this coin from Brandon. Can I throw this coin at you, Maddie? So Maddie has tails, 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 heads. We're gonna just keep flipping until 3 come up in a row that are the same, or that one of us pick, right? So we'll just keep flipping. If tails, heads, tails comes up, Maddie wins. If tails, tails, heads come up, I win.
Heads. Heads.
Tails, tails, heads. So what's the likelihood?
You picked two of the same.
Well, let's see. Either when I first played, I played Nathan first. What's the probability of me winning versus Nathan winning? The same. So what's the probability of me winning?
Because if you're just talking about first, but then afterwards, you have a very high chance of winning because repeats, and then no matter what, you were gonna win after the string of tails.
That's very good. Can you hold that thought for 1 second? Really, if you get this, you really get the whole chapter in probability, right? So if I'm playing a fair game and I'm playing against Nathan, and there's only 2 of us playing, the probability of me winning is a half, probability of Nathan winning is a half, right? And then after that, I play Brandon, the probability of me winning is a half, and then a half, right? So probably me winning the first game is a half, and then me winning the second game is a half. So probability of me winning 2 games in a row is a quarter. However, what's the probability of me winning 3 games in a row? An eighth, right? Because it's a half times a half times a half, which gives me an eighth. What's the likelihood of me actually winning 3 games in a row? An eighth. What about if I win the next game? What's the likelihood of me winning the next game? Very, very unlikely, right? So, okay. No, I'm trying to make a point here. What is the point?
If you pick second, you can win every time. Well, most times.
Did everybody hear that? If you pick second, you could win almost all time. So what's the probability of me winning? Is it 1/2? Paper and a pencil.
So someone chooses A, B, C, and you take A and B, bring them down here, and then you choose.
Okay, so another explanation is, say for instance, they choose heads, tails, then you take their first 2 letters and put them as your last 2 letters, and take the opposite of their first letter.